Dopamine was first synthesized artificially in 1910 by George Barr and James Ewens at the Wellcome Laboratories in London, England. Knowledge of its effects on the body was discovered later and is mainly due to the research of Arvid Carlsson and Nils-Ake Hillarp at the Laboratory of Chemical Pharmacology at the National Heart Institute in Sweden in 1952. Dopamine is named after its monoamine chemical structure, the synthetic precursor of which is 3,4-dihydroxyphenylalanine, L-Dopa. Arvid Carlsson was awarded the Nobel Prize in Physiology or Medicine in 2000 for demonstrating that it is a precursor substance for adrenaline and noradrenaline, and also acts as a mediator of brain neurotransmission. The chemical structure of dopamine, C6H3OH, 2CH2CH2 and H2, allows it to act as a hormone and brain neurotransmitter in a wide variety of vertebrate and invertebrate animals. Dopamine is a phenylethylamine, a catecholamine that acts in the central nervous system, basically fulfilling the function of facilitating nerve transmission, stimulating 5 different specific receptor types called D1, D2, D3, D4 and D5. Dopamine has a marked sympathomimetic action, being a precursor of adrenaline and noradrenaline, since it acts by causing an increase in heart rate and blood pressure when administered exogenously. For this reason, dopamine fulfills many functions in the brain, especially in the sphere of behavior and cognition, motor activity, motivation, reward, regulation of milk production, sleep, mood, attention and learning. In the frontal lobes, dopamine is involved in processing the flow of information coming from other brain areas, so that a deficit of dopamine in this region is responsible for neurocognitive dysfunction, especially memory, attention and problem solving. Altered dopamine concentrations in the prefrontal cortex are thought to contribute to deficits in attention deficit disorder or schizophrenia, so antipsychotic medication is commonly used to treat positive symptoms in schizophrenia. This is because an abnormally high level of dopamine is strongly associated with psychosis and schizophrenia. Dopamine-containing neurons in the mesolimbic tract are particularly associated with these symptoms, because an excess of dopamine in this region seems to be associated with the appearance of hallucinatory or delusional experiences. The interrelation of these events was understood more deeply after the discovery of a class of drugs called phenothiazines, which block dopamine D2 receptors, which are still used today for the treatment of schizophrenia, due to their ability to reduce psychotic symptoms. On the other hand, there are other drugs such as amphetamines or cocaine that significantly increase dopamine receptors, so they can also cause psychosis. This is the reason why most of the modern antipsychotic drugs currently synthesized, risperidone, olanzapine, are designed to block dopamine function. Another equally decisive function lies in the modulation of movement controlled by the basal ganglia of the brain, which is why in certain disorders such as Parkinson's disease, there is a deficiency of endogenous dopamine. To counteract this disease, it is possible to achieve an improvement in the condition by trying to compensate for the dopamine deficiency by pharmacologically administering L-Dopa, levodopa. This precursor of dopamine is capable of partially correcting the deficiency of this substance in the brain in patients with Parkinson's disease, since dopamine intervenes in the ability to execute fine and precisely controlled movements. Phasic dopaminergic activation therefore seems to be crucial in the internal coding of motor skills. Beck, 2005. Dopamine is commonly associated with the brain's pleasure system, providing the feelings of joy and reinforcement to motivate a person to proactively perform certain activities. It is a substance released particularly in areas such as the nucleus accumbens or the central tegmental area, secondary to experiences that exert an effect that provokes a feeling of reward naturally, such as food, sex and some drugs. Much has been theorized about this fact, to the point that today it is commonly accepted that most drugs, cocaine, nicotine, amphetamines, act either directly or indirectly, causing an increase in dopamine in these areas. Consequently, current neurobiological theories on addiction are argued on the belief that the dopaminergic pathways of addicted people are altered at a biochemical level. This is because dopamine is involved in the correct functioning of the brain's reward circuit. It has been observed that dopaminergic neurons respond with phasic activity to the presence of an unexpected reward, while they become silent when an expected reward is omitted. Living beings learn to repeat behaviors that lead to maximizing rewards, in the form of food, pleasure, well-being.